All right, so the last thing we want to look at today is the histogram. Now, this is a model that you have, I'm sure you looked at numerous times before in all kinds of subjects, but I wanted to look at a couple things in particular. These histograms can model discrete data. Remember, discrete data was things that were counted, and they had distinct gaps between the data. But it can also do continuous data in classes or groups. And that's what I'm going to focus the examples on here, but you could see how easily we could get the ones that are counted as well. So what is continuous data? Continuous data is data that is measured. It's measured. And it's measured so the values are going to spread across a continual scale. Even if you use a ruler and you're measuring something in inches, your ruler may only go down to a 16th of an inch or an eighth of an inch. And obviously there's a gap in between that and the next inch. So you measure the best you can, but at some point you're kind of rounding or just going to the closest spot. And there's a continual scale there, and you kind of naturally group things anytime you're rounding. Um, so to look at how we would construct a histogram and see this grouping even more clearly here, I want to look at some data, and we have the pH of 30 different water samples. Now, pH, if you recall from science, measures the acidity or alkalinity of a substance, of a liquid. So here we have all these pHs, and if you have a real good memory, you might remember that 7.0 is pure water. So these water samples are a little bit different. But what we're going to do first, before we try to model them, you'll see there's so many different values in these 30 samples. It'll be helpful to actually group them together. So you'll see here I divided this into 4 classes. Okay, so I have classes, a class where it is less than or equal to 6. So 5.8 and 5.9, there are 2 of those. So we would call it the frequency of 2. All right, so there are 2 pieces of data in this class. All right, and then we go from greater than 6 to less than or equal to 7. So here 6.1 is greater than 6. I'm going to kind of separate these classes here like this, all the way up to equal to 7. Okay, now this is important so you don't count the same thing twice. Notice I have it equal to 7 here, but in the next class, it's everything that's bigger than 7. Just like up here, it equaled 6. This second class includes things that are greater than 6. Okay, so that's important so you don't count the same data point twice. But here in this class or grouping, we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 there. And now we go from greater than 7 to equal to 8. So here's equal to 8. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then greater than 8, I have 1, 2, 3, 4, 5, 6. So we have 6 right there. Now, just to double check, add these up. 2 and 8 is 10, 24, 30. We were supposed to have 30, so I know I counted them all correctly. All right, so how do we make a histogram out of this? All right, well, first of all, I want to make, on my histogram, I want to make the bars the same width. So even though here I have everything less than 6, there was nothing smaller than 5. So since these are all 1 unit width, I'm going to make this bottom one a 1 unit width as well, from 5 to 6. And likewise, the one that's greater than 8, it's going to go from 8 to 9. Okay, and we can see in our data that there's nothing bigger than 9. So we can do that all right. Okay, so I look at this and I'm thinking about my scale. Along the bottom, we have our different pHs. And on the side, the y-axis, I left it blank intentionally here, the y-axis is always our frequency, the frequency. Okay, so we have to go up to 14. All these are even, so I'm going to actually count by twos. So 2, 4, 6, 8, 10, 12, 14. So there's 14, there's 2, okay, and I'm just going to label these here, okay. Now, for this part, it's really useful if you use a straight edge. That way your things turn out nice and neat, okay. So what I'm doing here is between 5 and 6, since there were only two samples that had this pH, I'm going to make my box like that, okay? And we typically will color it in as well. So there is our two items that have a pH between 5 and 6. All right, and then we have between 6 and 7, there are 8, okay? So I'm starting here, I'm going to go up to 8. And notice I'm not leaving any gap in between those, okay? And that makes sense if you think about the fact of the type of data we're dealing with here. I told you we were talking about continuous data. Well, continuous data would not have any gaps. There actually is a different type. There's a bar graph that you use only for discrete data, and we're not going to look at that here, but that does have gaps between them. So that's kind of a different one. I keep going here with my histogram. There are 14 in this class between 7 and 8. Let me try that again. Okay. Right there for me. There we go. All right, so there's between 7 and 8, there's 14. And then lastly, between 8 and 9, there are 6. Okay, so I'm going to go here. I'm going to go up to 6. Scooch that down a little bit. There we go. All right, and I'll color these ones in too, like I did the others. All right. Coloring them in isn't absolutely essential, but if you're going to do it, at least do it somewhat neatly. Stay in the lines. All right, so there you see it, all colored in and nice now. So let's interpret this a little bit. What do I notice about the data? Well, this one, we mentioned skewing before. This one, since there's only 4 classes, it's not as easy to see, but you can see we have these couple of lower values. So we might say this is a little bit negatively skewed or skewed to the left. And again, we're talking about what the mean is compared to where majority of the data is. So the majority of the data you can see is between 7 and 8. The mean is going to get skewed to the left a little bit here because of these low values. So we could say that it is approximately or a little bit negatively skewed, or again, we could say skewed to the left.